Welcome back to DC Thursdays. It's another Thursday, and we have another awesome guest on the show, which I'll introduce in just a minute. I'm Pete Soderling. I'm the founder of Data Council and Data Community Fund, as many of you know, and I'm here to guide you through the wild west of the data ecosystem. We've been fortunate to have on lots of awesome founders, lots of awesome open source project leaders and authors. Today we have someone who's actually floating across both categories, which will be turn into a great conversation. So before we get started and introduce our guest, I wanted to thank our sponsor, IBM, who's been supporting Data Council and the DC Thursday show. We're super excited and very grateful for them and their support. They have an online community for data scientists that you should check out. We'll put the link in the chat to the right of the video. So make sure you check out what IBM is doing for the community. They're believers in open source. They have NLP projects. They have ethical AI projects. They contribute to the Python community. And so we hope that you'll check them out and tell them that you are grateful for their support as well. As we do every week, we are going to open the chat to questions. So feel free to jump in at any time if you have questions for our guest. We want to make this sort of a cross between a podcast and a call-in radio show. So the best of all generations are right here at your fingertips. So feel free to sound off in the chat and we'll do our best to get to your questions. So without further ado, I want to introduce Matt Rocklin, who's here. Matt is the co-founder and CEO of Coiled Computing, which is the company behind Dask. And prior to that, Matt worked at NVIDIA. He worked at Continuum Analytics. He's obviously the author of Dask, which we'll get into, which is a fascinating story.
One of many, just to be clear. Lots of people, lots of companies. There's lots of Dask is a large community. If I don't say that, everyone else will jump on me. So
sharing the credit from the start, which is great. So thanks for jumping in. That's well said. Before kicking off or having something to do with kicking off the Dask movement, Matt was a researcher at Sandia National Laboratories. He has a PhD in computer science from the University of Chicago, and he also has a degree from UC Berkeley. So Matt, those are quite the credentials. Thanks for making time to chat with us.
Oh, it's great. I love doing these things. It's a fun, the whole, like, my story is like a small version of what, generally speaking, Python has been through over the last couple of decades. And it's a wild and unexpected ride, personally and from the community perspective.
And we were chatting about that a little bit before we came online, but we'll get into some ecosystem discussions about how Python has tracked over time. Before we do that, I just want to sort of understand the earliest days of your career, sort of leading up to your work on Dask. What were those days like? You studied math, you have a CS degree. Like, how did you sort of merge those things into this interest in data? Like, when did data start to become a thing for you? Did it become a thing for you, or are you just a distributed systems guy who happens to be sort of playing in the Python world?
Yeah, no, actually quite the opposite. So I actually started in undergrad doing physics and math and astronomy. So I very much came from more of a scientific practitioner's background. But I think as a kid, I had a little TI calculator that I would play with a lot and program on. And so I knew how to program, and that it was odd how much of an advantage that gave me back in 2000 when working on technology problems or working on science problems. And so I was never a very good scientist or a very good researcher, but I was an order of magnitude more effective at enabling my peers to do their research by helping them work through computational problems. And so that very quickly became a strong inducement to actually not do that science stuff, but kind of support scientists with computation. I ended up sort of falling into the US Department of Energy National Labs as a career track, because that's maybe like a good mix of sort of practical problems and technical problems. But in doing so, I was also working on the side in open source and in Python, and that just had like an order of magnitude more feedback, and I felt it was having a lot of bigger impact. And so pretty quickly after being at Sandia, I decided to jump ship, and I joined Continuum at the time, which then became Anaconda.
Mm-hmm.
It's where pretty much all of the sort of open source for-profit people went at that time.
Mm,
Anaconda was a really exciting time for anybody who wanted to have a big impact in open source Python and doing science and data science. That was where you went.
mm,
So that was maybe
mm,
my transformation. First
got it.
from science to computing, and then from maybe like academic-ish to open source, commercial open
Mm,
source companies, which were
mm,
very new at the time. It was still
mm-hmm.
quite strange.
Great. And so it was around 2015 that you dropped the paper on Dask, if I'm not mistaken. Is that right?
Yeah, a lot of things happened around that year. Yeah, so I was brought in at Anaconda to think about making Python faster. I had done a lot of open source work, and they wanted to attract people who could make Python more attractive generally. The idea being that so goes Pythons, or as Python goes, so goes Anaconda. Um, and Anaconda was concerned at the time about Spark, which was gaining a lot of traction at the time.
Mm,
Spark was this kind of like other data
mm,
processing ecosystem apart from Python, and there was some existential concern. And so I was thinking a lot about how to take the existing Python ecosystem and parallelize it. How do we take NumPy and Pandas and scikit-learn and what eventually became PyTorch and other tools? How do we scale those out to many machines? And that became lots of projects at first, but eventually Dask.
And so there's this notion of blocked algorithms. I don't want to get too much into the implementation details, but um, are blocked algorithms used both in Dask and in Spark? Is this the general category of processing that we're considering?
Yeah, let me think about that for a second. So Dask does many things. And so people sometimes ask, like, what does Dask do? And it does
Mm-hmm, mm-hmm,
lots of stuff. So I want to avoid putting it into a box.
mm-hmm,
But let me maybe answer a slightly different question, which is that, so with Dask, like we didn't want to do what Spark did. Spark recreated an entirely new data framework to solve data processing problems. With Dask, we had the Python frameworks already around. We had NumPy,
mm,
we had Pandas.
mm,
And so the goal was, well, if I have a really big data set, can I just have 50 machines, each of which are using just Pandas, and reuse a lot of that same code?
mm,
And so a lot of Dask's algorithms early on were around uh, pretending you had one big pandas data frame when you actually had
mm,
50 pandas data
mm,
frames, and then building parallel algorithms around them that reuse the existing ecosystem, the existing code we already
mm-hmm,
had from
mm-hmm,
decades of development. Um, so that's maybe a case where Dask and Spark differ a bit, and that maybe
mm-hmm,
brings up this idea of blocked
mm-hmm.
algorithms. How do we reuse what we have to gain something new, to up level our existing workflows?
I loved the framing of how you walked through that in the intro to the paper because you explicitly define that. Why would we throw away all this work and all these thousands of man hours of engineering time and research in the Python ecosystem that have been battle tested and tried and true, just because we can't run these things on multi-core machines? And so Dask was positioned literally as the infrastructure to bridge that gap. And I think it was really well said in the intro to the paper.
Yeah, it's a super interesting, super valuable, but also really hard problem. Like it's not just a technology problem. You've got to get into a bunch of different code bases. You need to get into a bunch of different communities. There's like a social engineering,
Mm-hmm,
um, cultural problem to address here at the same time you're building technology.
mm-hmm,
I think
mm-hmm,
Dask had to be really unopinionated and very receptive in order to have the kind of impact it's had. Again, not just with pandas. Pandas is maybe 20% of Dask usage. There's a
mm-hmm.
ton of other libraries that leverage Dask today that where Dask was put in after the fact. It's like it's like a turbocharger to your car, something you add in after
Mm-hmm. Mm-hmm. Well, then, so before we get into more specifics on what Dask is, what Dask does, those kinds of features, since you've sort of placed Dask against this backdrop of the Python ecosystem at large, explain to us what was going on in the Python ecosystem at that time. It was still mostly used for academic, scientific research purposes, no? Or are we like, what was it? I guess Google obviously has been sort of a big Python production user since the early to mid 2000s. But what else?
Yeah.
What like how do you sort of frame the industry versus research sort of curve that of Python adoption?
Yeah, no, there's like we could write a book about that topic. I'll try to constrain my answer to just a
Mm-hmm.
couple of minutes. But yeah, so Python started off as an academic educational language. Actually, it was designed to be easy to learn. It wasn't designed for data science. It wasn't designed for web programming. It was designed to be easy to learn in the classroom.
Mm.
That ended up actually being really, really useful for growth, right? Education tends to be a great way to get high growth if you're willing to wait 10, 20 years. Uh, Python then went into sort of web development and sysops. So that's maybe
Mm-hmm.
where Google was using it.
Mm-hmm.
A lot of web developers use Python
Mm-hmm.
today. Still not in data science. Then I think a lot of the MATLAB community shifted over.
Mm.
And so Python had really, really good connections to C and to Fortran. So it was very easy to take some of these existing scientific libraries that were amazingly fast, battle-hardened code. It's been around since the 70s and just like, runs your local nuclear power plant, but make it really accessible. And so that combination of speed and accessibility ended up speaking really, really well to scientists who at the time were, semi-technical, but not computer
Mm-hmm.
people, but
Mm-hmm.
wanted speed. And I think over time that ended up also being a really good proxy for data scientists. So I think Python really built out its infrastructure, serving the sort of scientific need,
Mm.
and that gave it sort of this head start on the same kinds of computational accessibility needs that data scientists and data engineers needed as well.
Mm.
So that's where I think we've seen Python to sort of like suddenly leapfrog into business because it has all of this very interesting history with science.
Mm.
As an interesting artifact, a lot of people in charge of all the of all the Python libraries, we all have a science background. And so if you look at, Jupyter was started by neuroscientists and quantum physicists.
Mm.
Scikit-learn also by neuroscientists.
Mm.
But there's this like weird history, everyone who's
Mm.
sort of my age in the ecosystem.
Mm. And so conversely, from a traditional CS perspective, you know, Python programmers were always kind of considered to be hacks, right? It was
We still are, yeah.
yeah. Didn't come from the hardcore computer science end of the spectrum.
Yeah, I'm actually very atypical that I do have a computer science degree. I'm
Mm.
like the
Mm.
weird guy who actually thinks about distributed systems, but I also can kind of communicate with everyone else in the community. Um, yeah, I think Python has always been a very pragmatic language, which maybe
Mm-hmm.
distinguishes it from maybe like Scala, which was like very
Mm-hmm.
sort of theoretically pure.
Mm-hmm. Mm-hmm.
I think again that pragmatism really spoke to the eventual need in business, right?
Mm-hmm.
And so if you look at history, there was maybe like NumPy and SciPy and scikit-learn, and then Pandas shows up. That brings in finance. Scikit-learn shows
Mm-hmm.
up. That brings in machine learning.
Mm.
The deep learning frameworks came in a few
Mm.
years ago, and that brings a lot of like heavier groups.
Mm.
So there's been this transition away from science into industry over the last, 5 to 10 years, based on how you count it.
And then, as you mentioned, even underneath that, there's this big underpinning of just mind share around Python because so many people had bumped into it or had a brush with it or learned it in school, or so there's this kind of quiet groundswell of all these folks who had experienced Python in some educational computer class or whatever. That was probably also meaningful in just a very broad sense.
Yeah, it's also, the fact that there is a web stack attached to Python is amazing, right?
Mm.
You can build your machine learning
Mm.
model and host it in the same language, right? And it's actually quite hard to do that in most other languages.
Mm.
There probably is a Flask for Scala, but like it's not something that I'm aware of, right? It's
Mm-hmm.
the fact that both of those are around are actually quite convenient in more of a production setting.
Mm-hmm. Mm-hmm. So your vision was to embrace the reality of increasing adoption of Python, especially in the scientific computing stack, and produce a more advanced system that could parallelize workloads and do it in a similar ecosystem that data scientists using similar libraries that they were already using in Python.
Yeah, I wouldn't say that's my vision, but that's our vision generally.
Mm-hmm. Mm-hmm.
People,
so what happened?
Yeah.
Go ahead.
People love using Python on a single machine. They run into a big data set, and there's this big, well, what do I do now question. And Dask more or less lets them continue doing what they're currently doing with sort of minimal pain to scale out, rather than having to rewrite in some other framework, MPI, Spark, custom queues, etc.
And what happened, I'm curious, when the paper was released? Was it obvious that you were onto something, or what was going on in your mind as the community started to respond to this this new info and this proposal?
Yeah, it's funny you mentioned the paper, because I think and no one reads that paper. It was written as part of a conference, the SciPy conference, which all of the Python maintainers go to every year. Um, most honestly, the biggest thing that sort of advocated for Dask was my personal blog. So actually, I live blogged the development.
Mm,
Every few days during development, I would talk about what I was working on, and that transparency, I think, actually brought a lot of other library authors into the project really early.
mm,
We had groups like Scikit-Image or Xarray or Pandas. Those maintainers started getting involved really early because they saw what we were doing.
mm,
We're also very able to shift development a lot. So
mm,
Dask was very nimble. We pivoted quite a bit in the first few months as we were getting used to working with these other library developers.
mm.
I would say within a small number of months, 2 or 3, we had excellent traction among other core authors. And then, a few months after that, we had good traction with their users, and that really caused our growth to increase. So
Mm,
Dask ends up being sort of more of an infrastructural player that ends up being sort of like an end user
mm.
tool or end user play.
Just so I understand, so is this to say that you were not just building an open source project and sort of, um, soliciting community contributions, et cetera, but you were also blogging in English about design decisions and architectural choices, and sort of you were showing your work, showing your mental work, if you will, sort of via blog posts, as you were also contributing code and pushing the project forward from a bytes perspective.
Yeah, absolutely. So I mean, I come from like an academic perspective, and I think a lot better if I'm writing something. That's just
Mm-hmm.
kind of what I do. And so yeah, Dask started very much in like a bottoms up way. We like made a little task scheduler. We then tried
Mm-hmm.
to do NumPy around that. We then tried to do pandas around that. We then tried to do lists around that. And all of those were little blog posts. We actually pulled all of those things out of my blog. They all now live at blog.dask.org. And so if you go to that web page, you can actually see down to the the first week of development. It was, I think, Christmas week. I was off on vacation.
Mm-hmm.
And you can see the very first thoughts that were going through our heads as we were working on it.
That's great. That's a really amazing story of the power of building something in the open and
Yeah.
and showing your work with the community.
And again, I think that comes from a lot of Python's principles of being more academic, a little bit more honest, a little bit more transparent, community-minded. That's had great, I think that has caused a lot of Dask's great success,
Mm-hmm.
is
Mm-hmm.
that strong transparency and community openness.
Mm-hmm. Awesome. So let's get into Dask a little bit more deeply.
My favorite topic.
Yeah. Now we can talk for hours. What are the main uses of Dask? Obviously, Dask is parallel computing for the Python ecosystem. Maybe you describe it differently. Would love to hear how you, sort of in your own words, what it is and what it's used for.
Yeah, I think that's the correct thing. So people ask, where is Dask used? My response is, where is Python used? And it's more or less the same set of situations.
Mm-hmm.
Maybe I'll answer that with an anecdote, which
Mm-hmm.
is
Please.
that the original goal of Dask was to parallelize NumPy. NumPy being this sort of multi-dimensional gridded data structure that's really, really common. It backs more or less all of the Python ecosystem today for computation. The idea was like, right, we're going to accelerate that, and then everything else will follow. That ended up not being the case. What ended up happening is we built that. We then built pandas on Dask, and then we showed that to users, and they said, about half of them said, great, this is what I want. I just wanted big pandas. I just wanted big NumPy. This is perfect. Then about half of them said, like, actually, like, I don't really want big pandas. I'm doing something way more complex than that. I'm building out my own
Mm,
custom thing.
mm,
But the engine that you had to build in order to parallelize NumPy and pandas, that engine is actually really, really useful to me. It is as though we had built a nice car. People said, great, I'll take the engine, please. So I'm building a rocket ship, or I'm building a submarine.
mm-hmm.
And this speaks a little bit to, I think, how Python is used, a little bit differently from how like most of the other data infrastructure tooling is used. I think a lot of us come from more of like a business intelligence standpoint, where you think you got a table of customers, you then want to run some SQL queries on it, do some lightweight machine learning. The Python users in organizations are often far more creative, and they're doing weird experiments. They're trying to bring in new different kinds of data sources. They're bringing in some
Mm,
audio files. They're doing some other weird stuff. that really breaks the mold. And so about half of Dask usage was enabling those other experiments. A good example of this is like Prefect is a company
Mm-hmm.
of workflow management, completely different from big pandas. And they're built on top of Dask, or they can use Dask under the hood to scale out, right? And the fact that Dask, like the Prefect authors saw Dask, said, oh, great, that's everything I need to sprinkle parallelism into my code base, this very different kind of code base, great. And so really Dask is kind of this, magic parallelism dust that other library authors put into their code.
Hmm.
But common use cases, I would say it's about a third big pandas, about a third big NumPy, which is imaging, MRI, climate science, big industry, and about a third wacky stuff, which is common in hedge funds. They've got really advanced trading strategies that are being run on Dask because it's just changing really quickly and they need a lot of sort of very custom stuff.
Mm-hmm.
Credit risk models inside of banks is really common. XGBoost deploys on Dask really comfortably. That's a very common combination point.
Hmm.
But yeah, a bunch of stuff. I'm happy to get into particular workloads, but the general answer is Dask is a very general purpose parallel computing platform, which has been so easy to integrate that now there's a lot of common use cases built around it.
Got it. And so what's a typical entry point into Dask for a sort of production workload or a team? Like when do you see somebody, is it because their pandas data frames processing just isn't scaling the way they want it to? Is it that I assume that's a sort of common on-ramp onto Dask?
That is a
Are there
very
others?
common prompt. Yeah, so maybe you're on your laptop and you have been working with CSV files that are hundreds of megabytes large. You have been given a 20 gigabyte CSV file and your laptop doesn't have much RAM. Instead of importing pandas, you import Dask and you just use Dask on your laptop to process that much larger file. That's probably the most common individual use case. So Dask is, it comes installed by default with Anaconda. Most people have it on their laptop today if they have sort of a data science stack. And it's just the easiest thing to get started with. And many people stop there, right? You can actually do quite a bit of computation on a MacBook Pro, right? So if you sort of get up to the 20, 50, 100 gigabyte level, like you're probably comfortable just on your laptop with Dask. Now you then go say, well, hey, actually there's this 5 terabyte data set sitting on my company's cloud. How do I get Dask deployed on my company's infrastructure to use it at scale? And that's like a whole different paradigm shift. And people love it when that happens.
Mm-hmm.
It gives you all this power that you're already used to, sort of the interface.
Mm-hmm. Mm-hmm.
It's very fun seeing people's eyes light up when suddenly they've got, not 4 little cores working on a laptop, but 400 cores
Mm-hmm.
working on the cluster,
Mm-hmm.
and it all feels the same. It really connects the remote infrastructure, makes it feel very close at hand. It's a really magical experience.
And it's the same, so just to be clear, it's the identical code base that scales to support all of these additional cores.
More or less, there are like slight differences. My favorite example here is, if you want to compute the median of a data set, it's very hard to do that in parallel. But Dask will provide alternatives like approximate quantile, and so there's some things that are different. But yeah, I mean the APIs, like the pandas maintainers also maintain Dask, right? When pandas makes a release,
Mm-hmm.
Dask releases in
Mm-hmm.
lockstep. Same with
Mm-hmm.
NumPy, same with scikit-learn, same with Jupyter. Like we've got the core maintainers of Dask are just the PyData core maintainers,
Mm-hmm.
and so there's a lot of effort to make that feel very very smooth.
Great. So then let's talk a layer lower. So then what is infrastructure deployment of Dask? Like what does that look like? If I am a data scientist and all of a sudden I'm hitting the limits of my MacBook Pro and I want to deploy to a Dask cluster, do you use the term cluster or
Yeah, sure.
so what has to happen at the infrastructure level in order for that to successfully happen? Is that something I can do as a data scientist, or do I need my IT team to kind of get involved and install
Yeah,
things, and like
that's
what
a
is
great
that?
question, and that's honestly what I mean. I think you're serving up a softball for me for. Well, yeah. So Dask, the open source project, deploys on any major resource manager that's available today. So you have a bunch of physical hardware somewhere on the cloud in an on-prem rack somewhere, and that physical hardware probably runs one of about 5 or 6 different resource managers. Kubernetes is an example of this.
Mm-hmm.
It's quite common today. Yarn is another one that's common on sort of older Cloudera Hadoop Spark systems.
Mm-hmm.
If you want to sort of like HPC systems, you get names like SGE, Slurm, Condor,
Mm-hmm.
LSF on IBM systems, etc. And Dask deploys on all of those. And so if you have access to those things and you understand enough about them, you can deploy Dask on whatever hardware you have. Now, what's common is that you're a data scientist in a company that has a cloud access with Kubernetes, but you have no idea how that works. And so I'm sure, Pete, could easily deploy Dask. But that's what we often see. We see early adopters in companies use Dask. And then getting sort of the rest of the company involved, things get a little bit trickier. And we can go into all the challenges that people face there.
Got it. So, so the Dask bits get installed on sort of a broad set of systems, and then they start to listen for workloads. I mean, is that the general idea?
Yeah, usually what happens is that Dask clusters are ephemeral. And so you say, hey, look, I want to look at this data set. You ask Kubernetes, hey, give me a Dask scheduler and 50 Dask workers. Kubernetes gives those to you, 10 seconds later. You can say, great, I want to go do some query. And then, those workers do some work, they fire off, they read data, they do some pandas stuff, they do some PyTorch things. They, then give you a nice little plot. And you show that in your Jupyter notebook or on your, batch process or whatever it is that you do. Then maybe you keep those workers around for a long time if you're going to keep doing that work. If you've got a really advanced system, your system will probably tell Kubernetes to scale that down so you're not taking up money. And we ask another question, it scales back up again, right? Bring the question of, do they stick around for a long time? Are they adaptive? That's a sort of an IT question.
Yep, got it. So then what are some of the main challenges that companies have in migrating to Dask? Obviously, you've seen many different types and sizes of companies and teams work to get onto this platform over the years. Like, what are the main pitfalls, gotchas, caveats, sort of like tips and tricks and hacks that you can mention that are insightful and honest?
Yeah, no. I'm not trying to think what the dishonest fun ones would be.
You're nothing but honest. So I don't know why I said that, but just trying to spice it up a little bit.
Yeah, no, I'll try to break the mold here a little bit, try to break the pattern. No, there's maybe two different kinds of users we would talk to. I'm now switching a little bit into for-profit mode. There's the small team case. So you, Pete, maybe you're a data science lead at a company. You serve 2 to 10 people in your team, and you probably use Dask, and you've used it. You did the whole Kubernetes thing we just talked about. You're super happy with it. Fantastic. There are then a bunch of extra challenges, right? Your teammates don't know how to use the cloud. They know how to turn on the Kubernetes thing on their cloud accounts. Maybe you end up sort of managing that for them. You turn into about a half to quarter FTE sort of DevOps person. Challenge. You probably leave the cluster on for a bit too long. So IT is kind of concerned that this stuff is running all the time. You've actually forgotten a few clusters that have been running for the last few months accidentally. You're also running Python code, arbitrary Python code at scale across your corporate infrastructure without any kind of security. And that might raise some concerns as well. You got a team to manage, but I want to think about off. Some of your teammates are more diligent about turning things off or on. So you want to make some policies and some quotas, some team management. And so there's there's a set of things you need to think about. And it ends up taking, an IT team 6 to 12 months to build some semblance of this. And those may be the common gotchas. This is where I think, so I've done this, I don't know how many times, different companies. We ended up making a separate company, Coiled, which just has that service and it has all those things built in, and it's super easy to use. And that's maybe one set of concerns. At the IT or top-down level, there's a different set of concerns, which is things like, how do I use these GPUs? How do I accelerate this credit risk model at scale? There's a set of business questions. How do I make sure that Dask doesn't break on me midstream? How do I get enterprise support? And so there's a kind of a different level of questions that happen at that larger scale.
And so you saw enough of these questions from enough users, you saw the growth of the Dask footprint and implementation numbers growing. And were you getting bugged by people in the open source community for more support than you can give? And hence, like, it's time. Like, it's this company like needs to happen. Was it that simple, or is there something more there?
Yeah, no, it's that times 10. Like, I honestly, I should have done
Mm-hmm.
this a few years ago. I mean, so for reference, I think like the Dask usage is quite high today. I think the Python Software Foundation did a survey. They survey all Python users. And I think when asked the question, which big data framework do you use? I think like 12% say they use Spark and about 5% say they use Dask among Python users. And so we're like kind of like below Spark, but above a tool like Hive, for example.
Mm-hmm.
So turning that number around, any company with around 20 Python users probably has someone in the company using Dask today. Um, and so the demand is very high. It was very high a couple of years ago. I was actually going to make a company a couple of years ago when NVIDIA stepped in and asked me to instead lead a team. They were sort of starting Rapids at the time. They wanted me to lead their sort of multi-GPU data science story. So I did that for a year and then started Coiled afterwards. But yeah, I mean, demand is quite high. There's certainly a business here. I should have done this a couple of years ago.
Mm-hmm. Mm-hmm. Well, that's great. I mean, this is an amazing indicator and proof point for other founders who might be building popular open source stuff, right? When you're able to release open source in the wild and see significant adoption, and the questions and the support requests come back to you, that's one indicator that the time might be right to think about commercializing something around it. Was that difficult for you to build a commercial entity around something that you had built in the open, in the wild, and had donated to the community via your open source efforts? Like, how did you think about that?
I mean, certainly making a company for anybody is hard. I don't think I've ever met
Mm-hmm.
anybody who said like, "Oh,
Mm-hmm.
this is easy."
Mm-hmm.
Yeah, no, my life is much less fun now than it was when I was
Mm-hmm.
managing engineering teams. Um, in terms of bringing in kind of a for-profit angle, that hasn't been that
Mm-hmm.
much of a problem. I think, I mean, I've always worked at for-profit companies when working on Dask, right? Anaconda generously donated my time.
Mm-hmm.
NVIDIA generously donated my time.
Mm-hmm.
Um, Dask is maybe distinct in the open source Python space that we always have been relatively well funded by for-profit companies. And yet we've also managed to maintain this sort of multi-institution, community-oriented transparency that I think you need to be this kind of infrastructural project. Like I think Kubernetes did this well as well, right? Kubernetes is maybe a Google project, but it's really managed by a bunch of different organizations.
Mm-hmm. Mm-hmm.
TensorFlow is maybe the counter example, right? TensorFlow is very much dominated by one company. We've taken steps to make sure that Dask does not feel like that, and so Coiled feels like my next thing, but not necessarily uh, fully encompassing of Dask itself. And Anaconda, Quantsite, NVIDIA, Capital One, these are all companies that provide a lot of support around Dask.
That's great. I think it's good for us as a community to have discussions around how the open source world and commercialization options are evolving, because as Wes McKinney has noted, his concern is like, is this really sustainable over time if we don't figure out some longer tail version of how open source developers get paid? Because if we're just looking to the big companies to subsidize your time to contribute to Dask or other big projects, like, is that the only model, or is there something that's slightly more robust and community driven that we need to be thinking about and talking about as well? This is obviously a bigger can of worms, but you might have some quick thoughts there.
Yeah, I've got lots of not quick thoughts there too as well. Um, yeah, maybe I'll share some thoughts that I think I came to while at NVIDIA.
Mm,
NVIDIA is a weird case, right? Because NVIDIA is definitely a for-profit company, right? There's no
hmm
illusion that they're not there just to make
They
money.
sell hardware. Yeah, right.
But they sell
Hmm.
hardware. And so this is
Yeah,
actually
yeah.
because they actually don't want software lock-in. They
Mm,
want hardware lock-in. And so
mm,
they're actually very much incentivized to be a good player when it comes to software, kind of one
mm,
layer
mm,
separated.
mm,
I think I gave a talk about this at SciPy 2019. If people want to go look at that talk. And I think that open source right now is in a good position because we have enough mind share that we can define the rules of the game, where those rules are protocols and conventions and interfaces that anybody who wants to have access to our users has to abide by. So for example, a lot of libraries today look a lot like NumPy, or they look a lot like pandas, or look a lot like scikit-learn, even if they're doing their own very proprietary stuff. And I think that while we still have that power, that control, we need to really harden and make sure those interfaces and those protocols are solid, and that defines the game that then all the companies can come into and play on.
Mm.
So at NVIDIA, for example, we worked very hard so that NumPy and a GPU equivalent NumPy could both work in a lot of different software libraries. And that required a lot of sort of community effort. But now, as a result, if Google comes in with TPUs or other hardware, they can play in that same level playing field.
Mm.
And so I think that's our goal, is to kind of solidify those contracts, those software contracts, so that everyone from now on is kind of forced into that convention.
Mm.
That's maybe an overly technical description, but I think we're at like a nice, interesting point right now to control the game.
Yeah, no, I love it. I think that's a great point. So just to sort of go back to the company, I'm wondering about some of your thoughts on go-to-market, right? Open source projects have a distinct advantage in some ways in getting this grassroots, bottoms-up community traction. But as putting your CEO and founder hat on, how are you thinking about enhancing that go-to-market on behalf of Coiled and Dask? Like, sort of, do you have a quick mental model as to how you're thinking about sort of pouring gasoline on this Python / Dask adoption in the enterprise? Like, where are you just going to let it ride from an open source standpoint?
Yeah, no. Yeah, I actually come from more of a consulting background. Like, I've had to fight for dollars in the past to fund people directly. This whole VC thing is new for us. So yeah, we're not just doing like straight up open source until we clearly dominate the space. I think we've kind of clearly dominated the space right now. And right now the goal is to capture that grassroots adoption and see what we can do to grow it and see what we can do to monetize it in the future. Certainly bottoms up makes a lot of sense for us. And we actually started with a top-down enterprise sale, mostly because I happen to know a bunch of finance companies using Dask today. We were urged early on to go bottoms up, and that actually was, I think, really good advice. We still have like 95% of our money comes from a few large enterprises, mostly in the financial services. But like 99% of our users are small teams. And 90% of our information coming in is small teams. So we're doing a bit of both. I would say for the next year, we're probably very much focused on bottoms up. And that's that sort of team lead role that I talked about before. And that conversation is just really repeatable. The sales cycle for that is weeks, not years. And that's like definitely been a lot more informative than the sort of long selling to IT, selling to top-down sales cycles, which we've done, but it's like, it takes 9 months, and we're 12 months old. So it's we had to do something in those intervening 9 months engineering-wise. But it is a challenge. Like, we have enough large finance companies and enough like government organizations, for example, all of whom want to use us and all of whom are very strictly on-prem, that there's many millions of dollars in ARR we could capture if we wanted to. We don't have to. We've got venture capital money to like do this bottoms up thing for a while. But it's very tempting to go back over. Lessons from Databricks or Snowflake say go bottoms up, but it's not entirely clear that that's the right case for us. It's an interesting thing to think about today. I think it's a very open and very interesting question.
Well, I'm really curious to see how this evolves for you. I mean, obviously you're a community-oriented kind of a guy, but it's nice that at least that there's big company interest and there are revenues to capture there, depending on sort of how the company might want to pivot its go-to-market if that becomes necessary in the future.
Yeah, I think, again, bottoms up makes sense. We're kind of building all of those warm leads in the future. But it's nice knowing that we were able to close large top-down deals, because it makes it very clear we're on the right path. And so the plan is, make a few large enterprises happy while building out a large set of customers, and then, a year or two or three in the future, turn those smaller customers into larger customers.
Great. Besides the go-to-market questions, like what's been the most challenging thing about starting a company as an engineer? I think there's lots of people in our community who would love to know like what's waiting around the corner for them.
I would say there's not a most challenging thing. There's a every couple of weeks there's a new most challenging thing. It's a job that never stops changing. We've actually started hiring a bunch right now, and actually been really having more seasoned people in the company. Realizing I don't have to do everything on my own has been a huge weight off my shoulders. That first year was really, really hard. Maybe that's a good lead into a solid piece of advice. I think as maybe like a good engineer or a good manager, I'm very used to being able to say like, look, if things are going slowly, I can just like put my head down and solve this problem quickly. And I think now that I'm no longer good at my job, right? Like being a founder, being a CEO, like it's just a constant flow of not being good at your job. I think learning to delegate more is probably something that people with my background probably do need to figure out sooner rather than later. Yeah, and learning that you need to like rely on other smart people, I think is also something that the people I've hired have always been like they've been like extensions of me. I've like given them engineering tasks. And now I'm hiring people who actually are more experienced than me and are taking on functions much better than I can. And I think getting that shift where you're at the center of the organization rather than at the top of the organization is, I think, a shift that needs to happen, especially again for engineers, because we tend to be maybe high-performing individuals in the thing we've done.
Yeah, absolutely. I think an engineering founder has to learn how to hire two different groups of people. There's people who are fundamentally different than you, first of all, just in personality or approach or style. And then there's you have to build the sales org and the marketing org and the recruiting org, and there's all these different types of roles to hire for as well. So it's challenging as a founder to figure out one's path through all of these minefields, but it helps to have great investors, advisors, mentors, friends, other founders to talk to. So thank God we have a community of people who are willing to support us and in starting sort of bringing these visions to life in a way that actually can scale through a team when some of us haven't had huge experience in building huge teams before we've started our first companies. So
yeah, definitely. Just to echo that a little bit, there's a huge amount of empathy coming from other people who've done this before, which has been very.
Yeah, that's awesome. Well, I'm glad you're able to tap into that. I think it's a tremendous time to be a founder and to be starting a company because there's so many different kinds of help and networks of support that you can get right now. So it's a golden era to start a company for certain.
Certainly, yeah. And I'll also say, I mean, from an engineering perspective, like there are things that we've achieved through a company for the open source community that we never could have done on our own. So I'm going to put in my little call to action here for a second. So you asked before, hey, if I'm at a company and I want to figure out how to scale Dask, how do I do that? Right now, if you're a Python user, you can install Coiled. It's a Python library. You can pip install conda install Coiled, and you can import Coiled into anywhere you're using Python, and you can then like get a fully secure, fully managed, fully authenticated, fully controlled Dask cluster running on your cloud of choice inside of your own VPC and your own account in about 2 minutes, right? And so like that huge sort of DevOps problem that a lot of these early users were facing is solved. If you're willing to pay Coiled some fraction of what you would pay normally. And so I think that like, again, is a thing that we really couldn't have solved as an open source community. Building a service like that, I think does require a company behind it to keep something up running all the time, to hire different kinds of individuals to work on it. And that capability is genuinely novel. And that's a capability that has focused, if you go like the Dask conference from last year, a third of the conference was about how to solve this problem in different ways. And it's now like, I think Coiled has made it trivial. And that I think is a big boost to productivity, both for us as a company, but also to, climate science or medicine, or there's a lot of use cases that we're serving in our broader mission that I think are very well served by the fact that we have built this thing as a company.
Hmm.
It's
Yeah, that's really well said, and I think that goes back to the previous question about um, you not having cognitive dissonance over both contributing to open source and building a commercially viable company around it, because there are truly powerful things that happen on both ends of that decision that that couldn't exist otherwise.
yeah, the open source community is very good at some things. It's very bad at others. And you need a
Hmm.
healthy mix of nonprofit, for-profit institutions all mixed together. And building that culture is interesting, right? And that's, I think we've done a very good job of that in the Python space, broadly. I think Anaconda, for example, did that quite well. Um, but that's certainly a challenge, and there's lots of interesting back and forth. Um,
Hmm. Hmm.
yeah,
Yeah,
it's
for sure.
it's fun. I hope that continues. Maybe going back to Wes's earlier point, but I think right now we're in a good spot. There's a lot of money floating around. There's a lot of respect to open source contributors and community. It's a good time.
Hmm.
I think
Hmm.
companies like ours are furthering that same good time, but there's a fight to be made there, right? And we need to make sure that other shark-like companies don't show up
Right.
and just take and just monetize. And that's really a
Hmm.
concern that I and other folks like Wes have.
Well, yeah, that's really well said, and I've enjoyed the conversation, Matt. It's been great to chat with you.
Yeah.
Before I let you go, I'm curious if there's something that surprised you most about working in the data ecosystem over the years.
Um, I would say personally, been amazing fun. I think there's very few disciplines where you get to touch so many different kinds of problems
Mm,
fairly deeply. I feel like researchers everywhere just welcome you into their hardest problems,
mm,
asking for advice, and that's a really unique opportunity. I'd recommend this field for anybody who's sort of naturally curious about the world. I would say maybe a flip to that. It's also very surprising how frequently their problems are all the same problems. And so I think we're also like well positioned playing that role to unite a lot of these different groups and bring them together. Um, so if you go to, again, a Dask conference, maybe another call to action, if you go to summit.dask.org, we're doing a user conference in May. So people who are
mm.
interested may be interested in subscribing to that.
Great.
And you see astronomers, and you see geneticists, and you see hedge fund managers, and you see banks all talking about file formats. And it's actually very fun to have all those very smart people all in the same room. Um, it's great. Like it's a very interesting convergence of different intellectual disciplines that's happening right now, right around technology.
And that's summit.dask.org.
Yes.
Great. We'll make sure and put that in the chat window so folks can find that link easily.
Great.
Well, thanks, Matt. It's been great to chat with you. I really appreciate you being here with us today.
Yeah, this is a blast. Thanks, Pete.
So just to let our community know, there's a couple of quick things I wanted to run by with you. First of all, thanks again to IBM, who sponsored this episode and has been a big supporter of DC Thursday. Don't forget to hit subscribe and hit the bell icon so that you get notifications when we go live again next time. You can leave us comments about today's episode via our feedback form if you are willing to sound off and let us know what we could do better. We greatly appreciate that. And then finally, our next episode will be on March 18th, and we'll have Will Falcon, who's very involved also in the Python community, this time on the PyTorch side. And Will's the founder of a company called Grid AI. So he'll be joining us for our next DC Thursday on March 18th.